Hello student, and welcome to the course Urban Rail Transit Tracks, Stations and Yards. In the previous lessons, we learned that the rail and sleeper components form the backbone of the railway infrastructure. In the previous lessons, we learned that the rails and sleepers components form the backbone of the railway infrastructure, engineered to withstand the tremendous stresses imparted by the wheels of the passing trains. However, a fundamental question arises. How can the rail and sleeper be effectively fixed in place to ensure the continuity and the longevity of the track system? In order to answer that question, we need to know a very important part in the railway tracks, and that is railway fastening system. Rail fastening system, also known as rail fastening or rail fastener, is considered to include all the components which together form the structural connection between rail and sleeper. While the rail and sleeper can handle the vertical, lateral, and longitudinal forces, they still need a mechanism to counteract the dynamic and lateral movement generated by the train operations. In addition, vibrations are generated by moving loads mainly on account of geometrical irregularities in the track and due to the forces set up by the imbalance in the rolling stock. Rail fastening system, therefore, is developed to address those challenges by firmly anchoring the rail to the sleeper, preventing any unwanted displacement. With the help of rail fastening system, the rail and sleepers can be fixed either directly or indirectly. The rail fastening system is usually considered of rail clips, rail shoulders, railroad tie plates, chairs, fasteners, dock spikes, screw spikes, and track bolts. The fastening system have several important jobs. First, they need to be able to flexibly absorb the force from the train tracks and transfer them to the wooden or concrete blocks that support the tracks. This helps keep the tracks in place even when they are worn down. Second, they should reduce the vibrations and the shocks caused by passing trains as much as they can. Third, they need to make sure that the tracks stay the right distance apart at the correct angle. Lastly, in some cases, they also have to keep their electricity from flowing between the tracks and the supports. Fastenings are generally distinguished into rigid and elastic fastenings, and let's delve into the concept of the rigid fastenings first. Rigid fastenings are used with the timber or steel sleepers. The fastenings are designed, developed, and field-proven under extreme weather conditions and are favored for their easy-to-install designs. In rigid fastenings, the rail is connected to the sleeper with bolts or nails. During train passage, the rail compresses the sleeper, and part of the string is plastic, which means it does not disappear when the load disappears, resulting in the creation of the gap between the nail head and the rail. With successive train passages, the gaps grow, causing a gradual slackening of the fastening, which affects the safety and may be the origin of the derailment. In addition to the plastic string, high-frequency vibration may also contribute to the widening of the gaps and the slackening of the fastening. Rigid fastenings may be installed either with or without a sealing plate, the latter being the preferable solution. Since the early days of the trains, chairs have been used in the building and maintaining railways with double-headed rail, and that could be the earliest type of the rigid fastenings. Back in the 1800s, when the railways were first being created, people started using chairs to hold the metal rails onto the wooden supports called sleepers. These chairs were often made of cast iron and were placed at different spots along the tracks. The rails would fit into holes or grooves in the chairs, helping to keep them steady and prevent them from moving sideways. As railways grew and technology got better, they made different types of chairs to match changes in rails, materials, and shapes. For instance, when they switched from iron to steel rails, they changed their chair designs to fit new rails better. Rail chair consists of two jaws and a rail seat. Webs of the rail is held in the inner jaw of the chair, and the rail key is driving between the rail and the jaw of the chair. Since the left and right jaw of the chair are symmetrically designed, it is necessary to insert a rail key on one side of the rail for the reinforcement. The chairs in the railway track are designed with 3 reinforcement holes, 2 on one side and 1 on the other side. The function of the chair in the railway is similar to that of the iron tie plate in the ordinary rail fastening system, and both can support and fix the rail. The rail chair is installed between the rail sleepers and the rails, fixed with the screws and locked with the steel key. The train passes on the track and the chair distributes the load from the train from the rail to the railway sleepers, so as to achieve uniform force. The key in the railway are important parts used with the rail chair. The material of the key can be wood or metal. The shape of the rail wooden keys is generally straight, while the shape of the padlock keys and the spring steel keys are special curved, shaped similar to the letter W. While this method provided stability, it required a considerable amount of manual labor to install and maintain, and it was not always as effective as preventing rail movement or maintaining track alignment, especially as the train became larger and faster. Due to the drawbacks of the rail chair, the transition using chairs to using base plates brought several advantages. Therefore, Vignal rails are fixed to wooden sleepers with the help of simple type of fastenings such as spikes, screws, and bearing plates. Track spikes are big nails with a bent head. One type of the track spikes is called dog spikes because the head of the spike looks like the ear of a dog. They were historically used to attach metal train tracks to wooden sleepers or ties in railway tracks. These spikes were hammered into the sleepers through the holes in the bottom of the rail to keep them in place. Dog spikes were really common during the 18th centuries and the early 19th centuries when wooden sleepers were the main way to hold up train tracks. People used dog spikes before they started using more advanced methods like bolts and plates to fasten rails to modern concrete or steel sleepers. Dog spikes were used in the train tracks all over the world, especially in the early days of trains and travel. Countries like the UK and the US, which had a lot of railways in the 18th century, relied on dog spikes to keep rails attached to the wooden sleepers. Although dog spikes are widely used, they have limitations in their holding power, as they tend to gradually become loose over time, particularly in areas with high train traffic. The vibrations produced by moving trains can further exacerbate these issues, necessitating frequent maintenance. The installation and maintenance of dog spikes are labor-intensive and require specialized tools, increasing operational costs. Additionally, their susceptibility to wear and corrosion reduce their durability, leading to their need for regular replacements. Apart from dog spikes, there are other types of spikes which are used in special use. Round spikes are used along the anti-creep bearing plates for fixing rails to sleepers. These are also used for fixing assembly of switches onto wooden sleepers. The round spikes has a round section of the diameter of 80 millimeters, and its length depends upon the purpose it serves. Round spikes have become obsolete now. Thumb bolts are employed under the switches for fastening slide chairs to the sleepers. These are used at locations where the gauge is to be preserved. While round bolts and thumb bolts serve as alternative fastening solutions, they come with their own set of challenges. Proper alignment during installation is critical, as incorrect placement can result in a track misalignment, which poses safety risks and functional disruptions. Installing those bolts is a more complex and time-consuming process compared to modern fastening systems, leading to longer maintenance times and increased operational expenses. Like dog spikes, round bolts and thumb bolts are sensitive to the vibrations caused by passing trains, potentially causing loosening over time. They are also vulnerable to corrosion, particularly in the regions with harsh weather conditions or proximity to water bodies, reducing their longevity. In this lesson, we learned about the generation and function of fasteners and got to know the earliest type of fasteners. However, these type of fasteners, while capable of fastening steel rails and sleeper together, are not perfect due to their simple structures. In the next lesson, we'll explore several improved fasteners. Alright, let's conclude our lesson for today. See you next time.